Hello, welcome to section 7.6 in our algebra, and today this section is on motion. We are going to be solving motion problems using a system of linear equations. So motion problems, we had some solved with one variable back in chapter 3, and now we're going to take a look at some motion problems with two variables, and sometimes it's a little bit easier using two variables to solve these problems. You can be solved easily by using a system of equations with more than one variable, and the basic motion problem is rate times time equals distance, or distance equals rate times time. Now, let's write an expression for each of these following statements here. You have y miles per hour faster than r miles per hour. That would be the same as saying r plus y. Plus, of course, obviously, means faster or increase. Then, if we say we have a rate of speed with w miles per hour, or w miles per hour tailwind, we would say the rate plus w, the rate of the speed plus the tailwind. The tailwind is the wind that comes along, like when we push a model car, okay, there's a tailwind, or a little bit of a wind at the end after the car passes through. That's called the tailwind, and that adds rate to the rate of speed, because sometimes that tailwind, or if you're flying in an airplane, the pilot will often talk about the tailwind, and depending on the wind that's blowing, it could either slow down the airplane or speed it up. If we have a rate of speed with the tailwind or the headwind, because that comes in the front, then that's going to take away from the rate of speed. So we have r, the rate, minus w. Now, let's say we have a distance flown at 5 hours against a w miles per hour headwind. So that means headwind, again, we're going to subtract. So our distance equals the rate times the time, right? So our rate minus headwind, and then times the time gives us the distance. That's the same as our formula. Distance equals rate times the time, or rate in this case times the time, the 5 hours. If we have another distance flown in 2 hours with a w miles per hour tailwind, how would we write that? Again, distance equals rate times time. So our distance is equal to the rate, which is r plus the w. Remember, tailwind adds to the rate, headwind takes away from the rate. So here we have the rate plus the tailwind. That's our rate times the time, 2 hours. That is going to give us our distance. These